One of the important things when you're working with the KNN algorithm is to figure out what is the best value for k, or the number of the nearest neighbors to choose. And in this example, I'm going to tell you how to do this. So the very first thing that I've done is just I've loaded NumPy and pandas in my workspace. And then what I am going to do is to use a built-in data set and show you how you can implement KNN and how to choose the appropriate value of k. So the very first thing is that I'm going to import a data set called breast cancer data set from the sklearn library. And the way that I do it is just I type from sklearn dot datasets import load underscore breast underscore cancer, and then I put that in an object called cancer, so that I don't need to type in the whole thing every time that I need that, right? So when I do this, I am going to have a data already loaded for me, and in order to have a idea of what this is, let's just print it. Let's just print cancer, and you see that this is a very messy output because it is a JSON file. So what you can do is to go ahead and let me just type it here. Sorry. Examine the data set, and I can just use the format and type in format cancer.data.shape. So this is going to tell me, how my data set looks like. Let me see what's the problem here. Again, it's that I have had a typo. All right, so this basically says that the shape of the data set is 569 by 30. So there are 569 observations and 30 columns, or 30 variables in the data set. The other thing that you can do whenever you're working with a JSON file, as this one, you can use the format to see the keys of the data set. So you can type in format.keys, and that will give you the keys into your data set. So you have your data and target. So data would be basically the features, and target is the label. Frame, target name, description, feature names, and file name. And for example, you can type in print cancer and look at the description. And here you would have a description of the data, cancer data set. So number of instances or observations, 569. Number of attributes or features, there are 30 numeric predictive attributes and the class. And then here is a description of the attributes that you have. So radius, what it means, texture, smoothness, compactness, and all those things that are features of breast cancer. And here you would have a summary of statistics and so on. What other things that you can do is to, for example, look at the feature names. So you can just say format and say cancer and figure out what are those feature names. And here you would have the feature names, right? Mean radius, mean texture, perimeter, blah, blah. These are all the features that, the names of the features. And then most importantly, what we want to do here is to also look at the target names. So what are the target names? And once you run it, you would see that the target names are malignant and benign, right? So basically what this data set is a set of observations that present a bunch of features of different cancers, features of cancer, right? And then the classification is whether or not that cancer is benign or malignant, right? And as you can understand, the value of the machine learning here is that if you can come up with an algorithm that looks at the features and learns from this features and labels, and then can predict whether or not, or can classify whether or not a cancer is benign based on the set of features that we are feeding it, then it would be such a huge help in healthcare. So let's go ahead and create our testing and our training and testing data sets. So I'm just going to say creating the training and testing data sets. And it's just like before, with a small difference. It's much easier right now because we are working with a JSON file. So we can say from sklearn dot model selection import train test split function. This is the exact same thing that we did before. And then we're going to have xtrain, xtest, ytrain, and ytest, just as before. And then we're going to say use this function that we just imported, train test split, and use the cancer data. However, here's the important thing. So basically from the cancer data, we're going to say that use the data portion, which are basically the features portion, to assign it to the X or the features here. So the xtrain and xtest are going to be based on the columns that are under the data label in our data set. And the Y is going to be based on the columns that are under the target name or target category, okay? So basically, it's basically saying to Python that go and look at the cancer data set, assign the portion of the data set that is under the category of data to xtrain and xtest, and assign the portion of the data set that is under the category of target to ytrain and ytest. And that target is basically the classification of the cancer, which is malignant or benign, and then the data portion are those 30 different features that we just showed you. All of these are portions of the data type. Okay, now one other thing that we have to add here is basically the random state. As we talked before in the other video, it just makes sure that whenever we run this code, we get the exact same answer. So you can repeat the code that I have, and you will get the exact answer that I get without any variation due to randomness. All right, so let's run this. And it runs without any error. Now, just so you know, I'm just going to take a look at the say xtrain data set. And you see that it is a subset of our data set with 426 rows and 30 columns. Okay, now what I have to do is to go and just like before, import the kneighbors classifier from sklearn. So I'm going to say from sklearn dot neighbors import kn or kneighbors classifier. And you know, in the previous video where I showed you how to use the simplest version of KNN in which the number of neighbors, or k, was equal to 1, this was the way that we did it. So we said that KNN is equal to k neighbors classifier, and the argument in the function, or the n underscore neighbors, was set to 1, all right? When you do this, basically you're running a KNN in which k is equal to 1, right? What I want to do here is to see, okay, should it be 1, 2, 3, 4, 5, what the number should be, all right? So the way that I'm going to do that is to calculate the training accuracy and accuracy in my test dataset and training dataset based on different levels of neighbors, right? So I'm going to go from, say, k is equal to 1 all the way to k is equal to 11 and calculate the accuracy both in my testing and training data set and see which value of k gives me the highest accuracy. So let me just delete this because you don't need this. So I'm going to create 2 empty arrays and then call the first one training accuracy. And it's blank, right? There is nothing in it. And then I call the other one and call it testing accuracy. And again, that is blank, right? Then what I'm going to do is to create a sequence of numbers starting from 1 all the way to 11. So basically, I'm going to create a range going from 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And those are going to represent the number of neighbors, right? So I'm going to use them to represent the number of neighbors. And that is, so I call it neighbors, neighbors. And that is going to be a range of 1 and 11. So what this does is that it creates a range, and it will be between 1, 2, 3, all the way to 11. All right? Now, basically, what I have to do is to implement the KNN classification algorithm 11 times, and each time I'm going to change the number of neighbors starting from 1 all the way to 11, okay? And as you can imagine, I can do that with a for loop. So I say for, say, number of neighbors, this is my counter, okay, in neighbors. Okay, so what I'm doing here is that, see, these neighbors is the same thing here, right? This is the neighbors, okay? I say for all the values starting from 1 all the way to 11, that is what this part of the loop is saying. Do the following, and that is to run the KNN algorithm. Classifier with the n neighbors equal to my counter. The counter is number of neighbors, right? Previously, the n underscore neighbors was equal to 1, right? But here we're going to say, okay, it's going to be to whatever the number of neighbors is at that particular instance in the for loop, okay? And then I say knn dot fit xtrain and ytrain. Okay, so what's going to happen here is that it starts with 1 and then puts the number of neighbors equal to 1, fits the algorithm with that with one neighbor on X train and Y train. And it's going to, what I'm going to do is to calculate the accuracy in my training data set and in my testing data set, and basically put that into the arrays that I have already created here that are empty right now. So I'm going to just say the training accuracy dot append, which basically is going to put whatever the value I'm going to give it now at the end of the array. And the way that to calculate the accuracy, there are many different ways of calculating the accuracy. You saw the first method in the previous video. This is exactly the same thing with a shortcut. So we are going to say KNN.score, and when we do this score, we are basically doing the following. We are calculating the mean accuracy on the given data set and the labels, right? Just like before. So it's going to test whether or not, or at 1%, at what percentage of the observations we are correctly classifying an observation. So we are going to basically calculate the score based on X train and Y train, and we're going to do the same thing for the test accuracy on the testing data set. So we say test accuracy that append KNN score, and here we're going to have X test and Y test. Okay. Let me just run this to see if there's any errors. Okay, let me see. Okay, this is again another typo here. Classifier. Okay, another error. Let me fix this as well. Okay, this is X underscore train. Here's again Y train. Okay, now I corrected all the typos and it's running without any errors. Now, the important thing is that, once we did this, we have to be able to plot it. What do we have here? Basically, as a result of this for loop, KNN starts fitting the model with number of neighbors equal to 1 and repeats it for 11 times. And in each instance, it is going to calculate the accuracy in the training and the testing data set. And after each instance, it's going to save those values of accuracy or score in the training accuracy and test accuracy arrays. All right. So now that it is finished running, we have to be able to plot that data in order to see what went on, right? So I'm going to just say plotting the calculated accuracy levels, and I have to use the matplotlib. So I'm going to use import matplotlib.pyplot as, call it PLT, and the rest is very easy. So I just say plt.plot. All right. This is a plot that I want. And what is going to be my X? I want it to be my number of neighbors. And what is going to be my Y? It's going to be my training accuracy. So I just put it here. And then I'm creating a label for it. And I call it training accuracy. I do the exact same thing for the testing accuracy as well. So I'm just going to copy and paste it. So number of neighbors, instead of the training accuracy, I'm going to use the test accuracy. And I'm going to label it as test accuracy, okay? So let me fix the errors here. Oh, so the errors was that instead of, I should have used the neighbors that is going to go from 1 to all the way to 11. So here, instead of number of neighbors, I should have used that neighbors. And this gives you the chart. So just in order to enhance it a little bit, I'm going to put a label on these two axes, and I'm also going to add a legend. And to do that, you can just type in plt.ylabel. That is the label for the y-axis, and I'm going to call it accuracy. And I'm going to add another label for my x-axis. I'm going to call it, I don't know, number of neighbors. In parentheses, K. Oh, number of neighbors, fine. And I'm going to say, add the legend. And then once I run it, I will get this. So I have the number of neighbors, I have accuracy, test accuracy, and training accuracy. And what you see here is, let's focus on the test accuracy first. And the test accuracy is highest when the number of neighbors is equal to 4. And it seems like the training accuracy is fairly well at that point as well. So within this particular data set, it seems like the best results that you can get from KNN is when you set K is equal to 4.